Then you are going to continue with the integrated circuit 7432 that has four OR gates. That means this is the symbol for the OR gate, and this is the truth table for the OR gate. So you are going to do something similar to what you did in the first part. So you are going to check first with the pins number 1 and 2 for the two inputs, and the pin number 3 for the output. And the truth table says that when one of the two inputs is connected to the positive of the power supply, your LED should be on. Only when the two are connected to ground, the LED should be off. Okay, so let me do the connections and show you how it works only for gate number 1. So this is the integrated circuit 7432 that has these connections. Okay, the pins are shown in this figure. Pins 1 and 2 are inputs, 3 is output, 4 and 5 are inputs, 6 is output. Gate number 3, 9 and 10 are inputs, number 8 is output. 12 and 13 are inputs for gate number 4, and pin number 11 is the output. Okay, don't forget that you need to connect the positive of the power supply to the pin 14 and the ground to the pin 7. This is the 7432 ready for to verify the truth table for gate number 1. So the two inputs are the white and the red wires, green and white wires, and those two are going to be connected initially to ground, to the blue line. The pin 3, which is the output, is connected to a resistor, and from the resistor we connect the LED, the positive of the LED, to the negative of the other side of the LED, to the negative of the power supply. When I try the different combinations for the inputs, you will see that the LED goes on once I change the inputs to 1. When the two inputs are 1, the LED is on, and also when one of the two is on also. Okay, so this is what you are going to do with all the gates in this integrated circuit, and the same thing with all the others, the other circuits given in your handout. The next one will be 7402 that contains 4 NOR gates. Okay, you need to check the 4 gates connecting the 14 and the 7 to the power supply, and the 2 inputs in each gate, and the output of each gate to the LED. So the next one will be the 7400, which has 4 NAND gates. So this is the truth table. So you need to verify that only when the two inputs are connected to the positive of the power supply, the LED should be off. Okay. The next one will be the 7404 that represents a NOT gates. This integrated circuit contains really 6 NOR gates, because the NOT gates require only one input and one output. For example, you can see here 1 is the input and 2 is the output. 3 is the input, 4 is the output. 5 is the input, 6 is the output. 9 is the input, 8 is the output. 11 is the input, 10 is the output. 13 is the input, 12 is the output. And you need to connect the 14 to the positive of the power supply and the 7 to ground. Okay. The last thing that we will do in this experiment is we are going to work with another integrated circuit that we have in the electrical engineering lab. This circuit is the integrated circuit 7410. The 7410 is really a integrated circuit that contains 3 inputs and 1 output. So in this case, we are going to have only 3 gates, okay, because we are going to have 3 inputs. For example, in the pins, you can see that pin 1 is the input for gate number 1, pin 2 is the input for gate number 1, and I don't know, the output of gate number 1 is, we have another input for gate 1 in pin 13 and the output for gate number 1 in pin 12. Okay, so you have the description for each pin, and you need also to check the truth table. In this case, the truth table will be different because since we have 3 inputs, we can have different combinations, and in this particular case, as you can see in the truth table, only when the 2 inputs are in 1 is when we are going really to have the LED on. Okay, so this is a NAND gate with 3 inputs. 7410 is a NAND gate with 3 inputs. Okay, so this one will give you output when either of the inputs is connected to ground. When all the inputs are connected to the positive of the power supply, the LED will be off. Thank you.